Good afternoon, everybody. Like my father said, I'm Eduardo Infante. You can call me Eduardo Jr., or you can call him Eduardo Senior, or both way, whatever, or vice versa. Yeah. So, like Don Anilio said, I'm more of Cervantes kind of guy. So, not Shakespeare. So if you see that I'm stuck with a word that I can come to my mind, just say it. It will help me. So this is Globalpesca, depredation, and the attempt to dissuade it. So the word attempt is what we're trying to do. A little history. Globalpesca started its operations in 2003. So that's where all data that we have collected, or experiences that we have collected, started. At the beginning, we only find sperm whales, and almost there were no orca whales around. In fact, crew members, when they saw one, they tried to take a picture. It was very hard to see one. Like today, it would be a selfie, you know, probably. Around 2007, 6 and 7, we developed the cachaloteras, just like the name says, cachalots, where we were looking for stopping the predation from cachalots. Effectively, with the cachalotera sperm whales, the predation were reduced, and in fact, it was, maybe there is still a lot of the predation, but it's always the same. There is no change. So it's like part of the business, you know? It's like the oil, the gas oil cost. There's nothing you can do. It's something you have to buy. We have that parameter that we don't even care because it's always constant. It's not your luck. So from 2005, the orca whales predation started, and the cachalotera took a very special place. It did work at the beginning with orca whales. And with orca whales, of course, the first strategy was to evade them. You know, but after a couple of months or year, first the vessel arrived the orcas, started the depredation, the vessel go away, orca whales followed the vessel. They don't do that anymore. They just wait, and we have a reasonable doubt. We don't know if they stay because they know of the location, they know the area where they are, or they know that they are a line down there that at some point it has to be hauled out, you know? We don't know that. Let me tell you that I will make many affirmations based on our experience and guts. We don't have any scientist data that can support my affirmation or my statements. Okay. There is something. Okay, we then tried the orca saver, and at the beginning we have a little lag, but it very fast stopped working. So I will go over that. And because at what point we stopped communicating with Savewave and Mustad, who makes the orca saver. And we try to new our own methods. So that I will talk about them. This SASDO, what is the Orca Deterrent Acoustic Submarine System. So SASDO is very easier to say. And we have other things. We are trying new fishing art, what we call the orqueras. We are doing some observations with IFOP and SEQUA. We have implemented, talking with the IFOP, we're trying to implement something that allows us to estimate the depredation. We don't have a real parameter about that. We don't know what real the depredation is. And later on, we are starting a project of photo identification with SEQUA and IFOP, and I will go over that. So the first thing, so that was the table of context. So I will go through each one of those devices or things that I have just said. So the first thing is cachalotera, that most of you know, but someone asked me, or many of you asked me to show you how it works. So this is the main line. Like for us, it has something like 20 kilometers. So these nominal numbers, you know, it depends on the fishing master if there is going to use many lines in parallel, short lines, long lines in serial. So to talk numbers, we talk always about 20 kilometers. So we fish normally at 2,000 meters. So the line goes down and then goes for 20 kilometers at the bottom of the sea and comes up. And there is a buoy at both sides. So this mainland has what we call barandillos, and I have absolutely no idea how it calls in English. Trot line? Okay. So I brought here a trot line that we use. We have the weight, in this case a small, and the hooks. We use a manifold of 10 hooks. And they're not 10 hooks, it's very hard to have 10 hooks here. So this is how the trot line works. And this is, and this is the cachalotera, okay? So how it works? The trot line passes through the cachalotera, like this. Normally it's easier to see. You know, crew members have more experience than me. So this is like this. So when it goes to the bottom of the sea, has this weight put everything to the bottom. But this floats. So this stays like this. Okay? Then the fish comes and the hauling process starts. When it starts, it's still floating until the rock stucks here. So because of the hauling, this tends to do like this. So let me put some. It's supposed to. Okay, I think you can make an idea of how it goes. This system, like I told you, is still working for cachalotes, sperm whales. We don't want to stop using it. And at the beginning, it worked with orca whales, but they learned fastly how to dissuade it. When they gathered together at the feast, eating toothfish, the mother teach their calves how to take the toothfish out. For example, the mother holds this part with the nose, so it exposes the toothfish, and then the calves arrive and pick it out. They have always, sometimes they took everything out, everything, just to play, everything out. So there is a big problem. This system doesn't work with orca anymore. That's we tried the orca saver. We tried it for 7 fishing seasons. I put that number because our seasons may take from 3 to 5 months. So it's a long time. Each time that we try to do something new in the vessel, we do something, and then we have to wait 5 months to see the results or to do something else. So that's why for me it's important that saying 7 fishing seasons is a lot of work. So we really tried to use this system, and it didn't work. The closest thing we have once is like orca whales stay like 400 meters from the vessel. And suddenly, after 2 weeks, they start coming closer. And the process began with one male. That one male was always trying to get closer to the vessel and coming back. Get a little closer and coming back. And then the whole family start getting closer. But it was always the main male who was doing this job. Again, this data is what I got it talking with people. There is no scientific or data that I can support any of this. We found some problems here with orca saver. It just had, and those models just had 3 preset signals. So naturally, orca is very adaptable, so this didn't work, or worked very, very good. It's very hard to operate. We needed 1 people with the winch that pulls this down, and the other one that is going with the power cord, and 2 others that have these lines to to avoid the orca saver to club the vessel. So, but the most important thing is it doesn't work dissuade an orcas from preying. So at this moment, what we did, like I told you, for some reason we stopped talking with orca saver guys, and we said we have to do something for our own. So and we didn't know what to do. It was a desperate situation. So we talked with a company called Intep. There is a consultant company that has nothing to do with the sea or fishing. They were an astronomer, an electrical, a signal engineer that has a PhD in Japan. Well, nothing to do. So they have a fresh look of the problem. The conclusional system found in literature have failed. There are not enough studies about Chilean orca whales and their behavior. New studies are mandatory to find a solution. Due to orca high adaptability, it's hard to believe that a single system will prevent depredation. A multi-system strategy is needed. So that's the conclusion that an astronomer got seeing this problem. Technology, one of the things that they found is a technology called LFAST, Low Frequency Active Sonar. What the military, USA military, use this technology with high power and very low frequency, so to map the whole ocean. They can see from the state what is happening in the ocean until Europe or wherever. They have very long. And there are some studies or some that said that have correlated this LFAST use with varamiento masivo de ballenas. Okay, you got the point. So, of course, we didn't want to make any damage to the orcas, but we said, okay, of course, if it starts a fire here, everybody will burn. But if you light just a match, you will burn your finger, and there's nothing. You can heal very fast. So we took that different approach. We didn't want to interact where the orcas are stronger. They know their language, they know their frequencies, so they know how to manage their own system. We tried a different side of it. The conclusion of INTEPS is more a strategy that combines resources and LFAS. So this is SASDO. This is what we did. This is the second version out of 4, so we've been working for a while. And 6 fishing seasons we've been working with this. Like I told you, this is the second version. We have a new one. And here, what you see are 2 transductors that are very, very high. And at the bottom, there are some lights, and then we were trying to film, but that didn't work. But that's the main thing. Differences with Orca Saver, amplifiers and power units are installed in the deck, not in the unit that you have to pull down every time. Main frequencies, power, and waveform are adaptable. Okay, I will show you later that. And we have failure after failure until now. Until I don't know that it will work next week or next month, but the experience that we have this fishing season, I mean last 3 months, is like orca still eat, but they eat and go. So they not stay festing around mothers teaching calves or whatever. They just eat and go. So that was very important. So we're a little happy with this, and we're trying to keep studying it and proving it. Like I told you, we have here. You can see you can draw. We have with a tablet. You can communicate with the system, and you can draw the waveform you want. Or you can make whatever waveform you want. We have allocated a certain kind of frequencies that works better, so we can talk about that. I put this other, while we were trying different kind of things, we put a rail attached to the vessel. So we were trying to have the SASDO stick to the vessel and going down and up. We found out that the whole vessel is a huge speaker, so crew members couldn't sleep anymore. So I wanted to show you that because among all other things, when you are testing something, you discover things that you didn't imagine. About the orqueras, like we are also trying to change this and make something different. Here I'm showing you the 5th version out of 8. So we've been, like I told you, we've been working in this for a while. And we have tested it for 4 fishing seasons. The actual model is absolutely different from this, but it has the same idea. We try something that is a little bit stronger. So the same idea, when the rock is stuck in that good thing, it opens up, and a door closes at the bottom, so protects the fish all around. It didn't last for long. That you can think why it didn't last. It's very fragile, but it gave us a lot of light of where we should, or where we should stay the line of investigation, and we're very. We think that we will get somewhere. I don't know where, but we'll get. About depredation, we don't have any way to estimate. I've heard all of you say, no, there is a 30%. I don't know. We don't know how much they're eating. So the first thing is we start speaking with the IFOP and trying to figure out how to estimate. Well, what we did is very simple at the end. Each line, the holding line has 20 kilometers and 700 trot lines. So we mark it. We make a mark after 100 trot. And we counted fish, and we wrote down time, depth, and position, latitude, and so like this. What's the idea? A different guy observer from the deck. As soon as he sees an orca whale, he writes it down, okay? In the same system. This is all a database. So what is this? If you have a line that has first mark, I don't know, 1 ton. Second mark, 1 ton. Third mark, 500 kilos, and then 200. But the system, by other side, from the deck, someone saw an orca, you can take that, and you can estimate what could have the line have all around time. So that's one thing we're working. I'm just getting there. Other thing that we're working with SEQUA, Jorge Acevedo is sitting there, and IFOP with Christian Vargas back there, is, our crew members every day sees probably more orcas than any of the scientists in 1 month or a year of investigation. Any crew member can identify orcas. They know which families are. But all of this information is not formal. It's not scientifically workable, So how can we take all that information out of those heads? For example, when you go to the farm, there is a farmer that said, tomorrow will rain. But how do you know? Look at the mountain, there is this kind of cloud. There's a local knowledge about experience. But how can you put that into meteorology? So that's what we're trying to do. And we're trying, like I told you, we are trying to teach the crew members to recognize different, in this case, orcas. So with the help of SEQUA, we designed these things. It's a little paper, plastified, that has this little information, a little key to identify the orcas, and the main characteristic. We have the same for sperm whales and other whales. So what are we trying to do now is for example, making a photo contest. They love photo contests. So making a photo contest of, I don't know, fins or tails or whatever. So that's one way that we're trying to put together photo identification and the crew members' experience. And that's it. That's what we've been working. Thank you.